Hello, dear friends. Welcome to my YouTube channel. At this platform, we're going to learn about different topics of chemistry. So we are going to learn various topics of chemistry. And today, our topic is a type of reactions that we study in our higher classes, that is graduation and post-graduation. So we shall be discussing about substitution reactions. Actually, this is a part of our further large and diverse topic, that's reaction mechanisms. So in this topic, we shall be discussing about nucleophilic substitution reactions. So let us move forward with our topic. Suppose we have a reactant, that's alkyl halide, wherein we have taken this tertiary alkyl halide R3CX. Okay, R3CX. This is a alkyl halide. And when we add a nucleophile to this reactant, what do we get? We get this new compound, that is R3CNU plus X minus. So what is it that's actually happening here? It's like this molecule, that is the reactant alkyl halide. In this, we have this X group that we call as leaving group. So this nucleophile that's present in here, it replaces this or substitutes this X group and forms the new compound, that's R3NU. And here the X minus, that is negatively charged species, is removed from this initial reactant. So this is the way in which a substitution reaction proceeds forward. So what happens? This nucleophile attacks at the carbon of this alkyl halide and removes this X group from there. Okay, so why does this happen? We all know that every reaction that takes place and leads to decrease in energy, decrease in total energy. Okay. Only if the energy of this product, that's R3CNU, if its energy is lower than that of this alkyl halide, then only the reaction shall proceed. Otherwise, this reaction may not be feasible at all. So, this type of reaction, that is nucleophilic substitution reaction, generally there are two mechanisms by which this reaction takes place. So we shall be discussing about the reaction mechanisms. Generally, there are three types of mechanisms by which a nucleophilic substitution reaction takes place. First one is SN1. Second type is SN2. And third type is SNI. What do these terms indicate? Actually, This is called as a unimolecular substitution reaction. This is called as bimolecular substitution reaction. And this mechanism, SNI mechanism, it is generally called as inversion mechanism. So, we shall be discussing all of these separately. So, first of all, we're going to talk about first type of mechanism, that is SN1 mechanism. As we already know, it is also called as a unimolecular substitution mechanism. Okay, is it clear? I hope it's clear. In this mechanism, what happens? Suppose we have an alkyl halide, that's R3. We shall be writing it like this. R3 CX plus nucleophile gives R3C X, not X, but it is nucleophile plus X minus. We have already discussed about this reaction previously. So now we shall be discussing about the mechanism through which this reaction actually takes place. So what happens? There are steps involved. So we shall be discussing about the steps involved in this reaction. First of all, what happens? This alkyl halide, or we could say that tertiary alkyl halide, because there are 3 alkyl groups attached to the carbon that is directly linked with this halide group. So this is called as a tertiary alkyl halide. So what happens? This X group, that is halide group, is removed from this molecule, and the resultant molecule that is formed is like this, R3C. So what actually happens here, that this bond, this sigma bond, that's made up of 2 electrons that are mutually shared by this carbon atom and this halogen atom. Both electrons go along with this X group. That's why the negative charge comes along with this halide group. And so if we balance this reaction, on the left-hand side of the reaction, we have no charge. That's all the reactants, the summation of charges is 0. So for making this a reaction neutral one, we shall be adding positive charge on this carbon atom. So a carbocation is formed. Carbocation is formed in this process. X is a leaving group. Now, as this carbocation gets formed, it becomes easy for the nucleophile to attack this carbocation. We shall be continuing. The reaction was like this, R3C X, and it gives us R3C positive plus X minus. So how does it take place? This X group takes this bonded pair of electrons along with itself, Now, what happens? This carbocation is quite stable, but not so stable that it may not react with anything. Actually, when a nucleophile is present around in the environment of this carbocation, it easily attacks this positively charged nucleus. Because it is a nucleophile, it's always seeking a nucleus to attack. So now, what do we get? We get a new complex that is R3C and U. And this is our final product. Or we can say that this product is the substituted product. I hope it's clear that in substitution reactions or this SN1 type of mechanism, the rate of the reaction depends only upon this reactant, that's alkyl halide. That's why we say that the rate of reaction in SN1 mechanism is directly proportional to the concentration of alkyl halide. Okay, we may also write this as rate is equal to constant into concentration of alkyl halide. Square brackets are used, and these square brackets indicate that we are talking about the concentration of any species. Square brackets indicate the concentration. I hope it's clear. So, let us discuss the energy profile diagram of this SN1 mechanism. Okay, let's move forward. Energy profile diagram. Suppose this is our graph, and here lies our reactant, that's R3CX. So what happens when it reacts? It goes to a peak wherein this leaves and R3C positive is formed. X minus is formed, plus nucleophile is always present there. Now, what happens when this nucleophile attacks this? We get R3NU, R3CNU. Okay. Now, I hope this is clear that the energy of reactants is greater than energy of products. We show energy in this coordinate, y coordinate, and in x coordinate, we show the reaction coordinate. I hope now it's clear to all of us that this reaction is proceeds through this mechanism, that is SN1 mechanism. Here we get an intermediate. R3C positive. This carbocation is an intermediate. We can easily separate this intermediate from the reaction medium by using special methods. Okay, let's clear this. Now we will be discussing the factors on which the SN1 mechanism depends. First of all, it depends upon the leaving capacity of the leaving group. So, let us take examples to understand this better. R3CBr, R3CCl, R3CF, and R3CI. It's clear to us we have taken the leaving group from the halogen series, that's chlorine, bromine, fluorine, chlorine, bromine, iodine, astatine. We all know that chlorine is the most electronegative element, followed by chlorine, followed by bromine, followed by iodine and astatine in the halogen series. Now what happens, the more the electronegative element participating in a bond formation, this bond is formed stronger